All right, well, good morning and welcome to the Guaranteeing Storage Performance in CloudStack presentation. So I did this same presentation about 2 or 3 weeks ago in Las Vegas. It took me about an hour. I think I have 30 minutes here, so I'm going to try to move it along in a fair clip, but feel free still to ask questions at any point. Just either raise your hand or just inject at any point and just ask away. So I'm Mike Tutkowski. I'm actually full-time on developing CloudStack. I'm a member of the CloudStack Project Management Committee as well. I work at a company in Boulder, Colorado in the US called SolidFire. We develop a clustered storage area network technology that's based on industry standard hardware, and it's an all-flash array. So the main purpose for our SAN is to guarantee quality of service on a volume-by-volume basis. And how that translates into CloudStack is providing you with the ability to select what we call a minimum, maximum, and a burst number of IOPS. So every volume in CloudStack that you make, you can actually select not only its size, but its performance characteristics. I feel like I should be smiling when the camera comes by. Anyway, so it's an all SSD array. The reason it's all SSD is because to create a truly performant quality of service system, you need consistent latency for every I/O. And so having it on spinning disk just doesn't work for true quality of service. Sometimes I get the question then, well, isn't it really expensive if it's an all SSD array? The next point I was going to mention here is that we use compression, deduplication, and thin provisioning at a 4 kilobyte block boundary to really bring the cost per gigabyte to be on par with traditional disk-based arrays. So it's actually very price competitive as well. The final point here I was going to mention is there's a comprehensive REST-like API where, if you're familiar with CloudStack's API, it's very similar. And this allows us to, including myself as a CloudStack developer integrating SolidFire into the product, it allows me to automate all aspects of the SAN. Everything I need to do with the SolidFire SAN, I can do through its API, very similar to interacting with CloudStack. Again, I guess for the sake of time, I'm going to move on. I'm not sure how familiar everybody is with the general architecture of CloudStack, so I'll spend a moment here just mentioning the concept of zones, pods, and clusters. So a zone, an availability zone, would be essentially your data center. The pod would be a rack within your data center. And then your cluster is where your hypervisors like KVM, ESX, and Zen Server come into play. And traditionally, this is where primary storage has been introduced into CloudStack. Traditionally, when I say that, I actually mean prior to the 4.2 release. As of the 4.2 release, primary storage can also be put at the zone level. But in this particular sequence, the flow I'm going to go with, I'm going to start with the way things were prior to the 4.2 release. And then once we hit the 4.2 release, there were a lot of big changes in the storage framework. The largest one was that vendors, such as myself, we're now able to develop plugins to integrate with CloudStack. Prior to that, you had to integrate with CloudStack either as basic iSCSI storage or as NFS storage, essentially. There was no real way of me taking specific snapshots on my SAN or doing anything like setting my quality of service options. So 4.2 is really where that came into play. And we'll kind of follow through a sequence here showing you how storage worked prior to that release. And it still does work that way, but there's a lot of really cool enhancements as of the 4.2 release. And I leverage those to deliver guaranteed quality of service in CloudStack. So also, I guess, just to point out, secondary storage, that's storage for your ISOs, your templates, your backups, that lives at the zone level. And that's still true today. Let's see here. So little bit of differences between primary and secondary. We're going to focus on primary storage today since that's mainly where I spend a lot of my time. As I mentioned, secondary storage lives at the zone level. That's mainly storage for templates, backups, ISOs. What we're talking about today is primary storage, storage for your root and your data disks. So when I say root, sometimes people ask me about that as well. Root disk would be like a bootable disk. And then data disks are additional disks that you can create, attach to your VMs. Your applications can write data to those disks. Those disks can be, if you want, you can detach them, attach them to different VMs. And so the data is a little bit more mobile in that sense. All right, so what's primary storage prior to the 4.2 release? I know it says pre-4.2, but this is actually accurate as well in 4.2 and beyond. It's just that in 4.2 and beyond, there's additional enhancements to the storage framework to make it more than this. But before the 4.2 release, what did we have? Primary storage, as I mentioned earlier, was exclusively associated with a cluster. The cluster could be associated with one or more primary storages. And the primary storage itself could be either shared or local storage. So if you have, say, a Xen server host, it might have a 100 gigabyte disk. Maybe 8 gigabytes of that was devoted to Xen server, and the rest of it might be contained in a local storage repository. That could be consumed by CloudStack as primary storage, and you could use that storage to run virtual machines on. And then, of course, there's shared storage, which is NFS-based, iSCSI-based, usually living out on some kind of NFS share or a SAN. And we've already mentioned the root disks versus the data disks, two main divisions there. So depending on your hypervisor type, how you actually incorporated this storage into CloudStack is different. And just for the sake of time, I'm just going to walk through a quick example on how to do it with Xen server. And then we'll get into the newer 4.2 stuff. But once we see how this works in the pre-4.2 era, then we can sort of appreciate some of the enhancements in 4.2. So provisioning, how did you actually do this prior to the 4.2 release? And again, it's still completely valid today. It's just that there are additional ways of doing this. Prior to the 4.2 release, it was a very static process. Everything was done ahead of time. You went off to your, let's say here, I'm going to use SolidFire as an example. You might go off to your SolidFire GUI, create a large LUN, maybe 8 terabytes, maybe a bunch of 2 terabyte LUNs, just something very large. The idea there being that you're going to host multiple virtual disks on that LUN. So once you've done that, your next step, and this is all manual, your next step is to go over to the hypervisor. If it's Xen server, this is when you go and consume that iSCSI target as a storage repository, which is basically creating a clustered file system on the LUN and preparing it for your virtual disk images. So now you've gone from SolidFire over to Xen Center, and now you're finally able to come into CloudStack and consume it as primary storage. Once you've done that, you can tag it. I'm not sure if people are familiar with storage tagging, but it's a way of just describing some characteristics for your primary storage. It could be really generic, like it's fast, SSD, or it could be something very specific, like it's SolidFire. However you want to do it, basically. Once you've got that in place, though, you can go into the Service Offerings tab, make your compute offerings and your disk offerings. And again, because I don't really know how familiar everybody is with that terminology, compute offerings are basically templates for how to create your virtual machines. They specify how many virtual CPUs, how much memory, and then one of the things you can specify is the storage tags that are applicable to house the root disk for the virtual machine. So when you spin up a VM based on that compute offering, CloudStack will look at the storage tags of your compute offering and see if it can find primary storage that can satisfy those requirements. So if your compute offering just says fast, well, maybe you have a dozen primary storages that describe themselves as fast. If there's nothing else qualifying this, CloudStack's free to put the root disk on any one of those particular primary storages. Same idea for disk offerings. Disk offerings are basically just templates that allow you to create additional volumes that can be attached to your virtual machine, but they use the same concept of storage tagging. All right, so let's just kind of walk through this a little bit more visually and just go through the process of what I just talked about. We're going to see it visually. Let's say we have to make a volume. I'm going to use SolidFire GUI as an example here. You go into your storage system of choice and create either an NFS share or, in my case, an iSCSI LUN. Obviously, providing the name, capacity. Usually, in this case, in the pre-4.2 world, it's going to be a really large LUN because we want to house multiple VDIs on it. So probably something like 2, 3, 4 terabytes. In the case here for SolidFire, since this is a system that has multi-tenancy included from the ground up, you actually specify an account to create the volume within. So you could picture different accounts like Coke and Pepsi, and those guys are isolated from each other, and they can't see what the other guy has access to. But the more interesting part is the bottom part here for SolidFire, where you actually specify the performance characteristics of the volume. So there's 3 options here: minimum, maximum, and burst number of IOPS. The minimum is pretty much what it sounds like. It's a guaranteed minimum number of IOPS. So as long as you're pushing the system hard enough, that's the performance that at least you will expect to see. Maximum, as long as the system has additional resources for you, is typically what you will see if you're pushing the system hard enough. And then the concept of burst makes maximum more flexible. So you could look at minimum like a guaranteed minimum baseline. Maximum is essentially like rate limiting. You don't go above that, except for if in certain cases, if you've been running below maximum, you'll actually accrue credits for not hitting your maximum. And then if you need to, say you have like a database transaction or something where you require an additional number of IOPS for an extended period of time, if you've accrued enough credits, you can actually burst above that maximum until you've expended those credits, and then you'll be reeled back down into your maximum. So think of it like minimum is a guaranteed number, maximum is a sort of like rate limiting, but burst makes it more flexible. Okay, cool. Now that we've got our iSCSI volume, let's head over to Zen Center and actually consume it as a storage repository. So I know it's probably not the easiest thing to read here. Maybe I can walk over here. Top left is where we start. We just say we want to make a new storage repository. And in my case, it's software iSCSI. So I just selected that. Moved on to the top right. This is actually the target host is the IP address of your SAN. Now, in my case, it's actually a clustered SAN. So there's a collection of loosely coupled nodes that creates the SAN. Picture them each as 1U servers, and each 1U server is a node. It runs our distributed software on it. You start with 4 of them, and then you can continue to build the SAN out from that point, 4 to 100, and you can pretty much mix and match capacity and performance characteristics based on what we offer, and that way you can actually control what kind of performance you add to the SAN versus capacity over time. So you can start small, grow it out over time, controlling the performance and the capacity requirements as you need to. So if you've got, let's say, 50 storage nodes, which node am I referring to here? There's actually the concept in our SAN of a storage virtual IP address. So it's essentially a floating IP address. One of the nodes in the cluster is hosting that storage virtual IP address. And should it go offline for some reason, let's say you're doing a rolling upgrade or something, you've installed the new software, now you need to reboot that box, one of the other nodes in the cluster will pick up on that storage virtual IP address and life will just go on. So that's the IP address in my particular case that I'm sticking in that particular field. Bottom left is just the name for the storage repository. In this case, it's probably a little hard to read. It just says SolidFire Gold. That's going to come in handy in a couple more screen or slides as we consume the storage in CloudStack. And then finally, on the bottom right is just showing it's a shared storage repository. So this is the compute cluster, and here's our two hosts in it. There's just two Zen server hosts, and that's our shared storage repository. So again, a lot of this, if it seems like it's sort of tedious explanation here, that's kind of maybe a good thing, because I'm trying to emphasize the point about how tedious this process was prior to the 4.2 release. You had to specifically go over to your SAN or your NFS provider, create your share or your LUN, then go into Zen Center. Now that we're done with this particular part, we're going to finally move on to CloudStack. So it is a bit of a tedious process, and all of this gets automated in the 4.2 release and beyond. And that's enabled through our storage framework supporting plugins, and then the plugin that I developed for SolidFire. So here we are in CloudStack, finally able to consume our storage repository as primary storage. We don't really have to spend a whole lot of time on this, but in this particular case, this is storage at the cluster level. So you do have to specify the zone, the pod, the cluster, provide some kind of a name for your primary storage. I don't know why I put an IP address in there. It doesn't have to be an IP address. I think at the time I only had one node in my cluster, and I just put that in as the name. But anything pretty much goes for the name of the primary storage. Pre-setup is one of the protocol options for primary storage for Zen server. That just means that I set everything up on the Zen server side. You don't have to worry about that. If you do not use CHAP, then CloudStack can actually set up your storage repository for you. In this case, I just happened to use CHAP, so I had to go to Zen server to set it up. And here I'm just telling CloudStack, it's already set up. I'm just going to provide you that name. So SolidFire Gold is the name of the storage repository, if we remember from a slide or two ago. So we're just sticking that in here. And then finally, we get down to our storage tags. And I guess just to make that a little bit confusing, I also named the storage tag SolidFire Gold. Of course, that can be anything you want. It's just a comma-separated list of identifiers. So we're going to see in our compute offering that we make, I reference SolidFire Gold as the compute offering, as the storage tag. I'm actually referring to this, not that.
But the name is fine. You need some IP address, I guess, right?
I'm sorry, what was that?
I guess the name is fine. You need to enter IP address, some connection point, right?
Oh, you know, actually.
It might be fine that you enter IP address, right?
Yeah, so actually, if you're referring to, like, how does it know where the storage repository lives?
Exactly, that's what I want to ask.
Yeah, that's a good question. So the fact that I selected this cluster, it knows which hosts are in that cluster,
Okay.
and that's where it finds out. Yep.
Okay, but that's, let's say back and talk to the Zen server and servers and stuff. It's not, yeah, okay.
Exactly. Yep, that's how it knows. And then it just knows to look for the SolidFire Gold storage repository. Exactly. That's a good question. Yeah, I mean, when I first started with CloudStack a couple years ago, I remember wondering that same thing, and then it was like magic. How did they know about that? And then I realized, oh yeah, of course I set up my cluster and I picked it here. I mean, that's exactly how that works. Yeah.
It's not like NFS. In NFS, you need to define, for example, IP address in the CloudStack, and here we're not doing that.
They're all different. Exactly. Yep. If you were doing VMware and you picked VMFS, there's different options. They just kind of like make fields disappear and appear, and there's probably half a dozen if you look at all the hypervisors, and they're all like a little bit different. So this is one thing that kind of is simpler in the newer releases with prior to 4.2 and beyond. So yeah, great question. Thank you. All right, cool. So now we're able to finally make a compute offering or a disk offering. In this case, I'm just illustrating a compute offering. So the basic stuff, the name, the description, how many virtual CPUs, how much memory. Then you get down to the storage stuff at the way bottom with the storage tagging. And I just put in SolidFire Gold. In this case, I only have a single primary storage that has described itself as SolidFire Gold. So the choice is going to be pretty easy for CloudStack to figure out where to put this particular root disk. Okay, moving on here. All right, so kind of to sum it up here, that bottom left, actually I should say this section here, right there. That's sort of what we just described. That's taking your large LUN, creating a storage repository, and then sticking a whole bunch of virtual disk images. They could be the root disk, they could be data disks, but they're all sharing that one LUN, which, if you remember, when we set the quality of service settings in the SolidFire GUI, we did it on a volume or a LUN basis. So that's great. We have guaranteed quality of service to that one LUN. The problem is here, if you have a whole bunch of virtual disks running on that LUN, there's no way to control how many IOPS one sucks up versus the other. So they can still compete with each other for that guaranteed number of IOPS. So the ideal way to set this system up is described over here, really with a one-to-one mapping. Every time you spin up a virtual machine, you are going to need to have a virtual disk image that represents the root disk. And we want to place that on its own back-end volume. So this really explodes the number of LUNs, which is difficult today for hypervisors like Zen Server and ESX. But these vendors are all aware of this, and they're actually moving to a model. In fact, I don't know if anybody knows Tim Mackey, but I was just speaking with him. He works at Zen Server, and they're in the process for their Credence release, which I think is the 6.5 release of Zen Server, of bumping the number of LUNs up from 256 per host to well into the 3,000, 4,000 range. So then this bottom right model of a one-to-one mapping between a back-end volume and a virtual disk really becomes a reality.
But this limit is per host, it's not per host.
Oh, yeah, that's a great question. So it is per host, but if you are, if you're, say you're in a Zen Server cluster and you have a shared LUN, even if only one of the hosts in your cluster, let's say you have 6 compute nodes, even if only one of them is actually using it, they all have to actually see it for features like live migration. So it really consumes it at the cluster level effectively. I mean, everybody might have their own local storage, so that consumes one from each of them. And then maybe you have 255 shared LUNs at that point. Now, I talked to Tim about this as well. He said that's not technically a hard limit. He's actually gone well into the 300s with the number of LUNs. But he said, I think what he was saying was that they've only really tested up to 256. But that would be, oh, right there.
It's also dependent on how many paths you're doing. So if you've got 8 paths in a LUN, the limit is the product of path times LUN rather than LUNs. So that's why Tim's saying you can go up higher.
That's a good point. Yes, yes.
If you're a 32-bit kernel, you end up with the amount of memory being consumed per path.
Yes, that's correct.
Really bad. Whereas on a 64-bit, it gets much easier.
Yes, yes. Thank you for that. Yeah, that's a great point. So ideally, once this next release of Zen Server comes out, this problem will go away for us. And there's a similar concept with ESX. They have the same problem right now. And vVols has pretty much been in development, virtual volumes, for like the past 3.5 years or something. It's finally supposed to be coming out next year, and it's the same concept. Pretty much every file on an ESX data store will be mapped to its own backend volume if VMware has its way. It may not have to go that extreme, but that's what they're thinking right now. So I guess the moral of the story is the hypervisor vendors are aware of this need for quality of service, and they're moving in the right direction to solve the problem on their end. Did you have a question? Yeah, no problem.
About KVM support, is there at all?
So KVM, yeah, as far as I understand for KVM, it's a little bit different.
There's no clusters.
Yeah, there's no real concept of a native cluster, even though CloudStack puts them in clusters. And so KVM, you could look at it like, even if it has 256 LUNs per host, it kind of is per host for real. And then I believe CloudStack, the way it works is if you want to live migrate a VM from one KVM host to another, it actually orchestrates the destination host picking up the new LUN, moving the VM, and then removing the shared LUN from the source host. So you have a little bit of overlap, but it's not, like you say, it's not really a native cluster, so they have different restrictions.
But do you have maybe some kind of, let's say this way, of maybe not really clear the cluster stack system as to regularize how this
Yeah, so from what I understand, and for me in particular, most of my customers for CloudStack have used Zen Server and ESX. Now we have another guy at SolidFire who works, he's basically me on OpenStack, and he almost works exclusively with KVM. But from my experience, I believe the hosts in the KVM cluster, only one of them, I believe, needs to actually see that shared line. Yeah, so it's a little bit different there.
Obviously, you have thin provisioning for all the ones. So
Absolutely. So I didn't really mention this too much, but one way to keep the cost per gigabyte down is that everything is, it's basically nothing is provisioned. It doesn't really matter on the SolidFire SAN if you make a 100 gigabyte volume or a terabyte volume. The metadata, the actual data, it's all thinly provisioned. There's essentially nothing made up front. And then as you write data to the volume, that's when you actually grow the volume. And then everything is compressed, and then it's deduplicated across the entire cluster. So it doesn't matter if this volume and that volume if they have exactly the same data. That data is only stored, well, it's stored redundantly on the SAN, but only twice. Each 4 kilobyte block is only stored twice. So if you have 100 volumes all with the same exact data, each of those blocks is only stored twice on the SAN.
on your previous slide, when you allocate volume, there was a choice of the size of blocks. Why are you doing this?
On this particular one?
No, on the SolidFire interface.
Oh, on the SolidFire interface, what I did was I picked the size of the volume that the host would see.
The block size.
Oh, that's a great question. Let me go back and talk about that. This is one of those areas that I spent a lot of time. That's why I mentioned it took so long to do the same presentation in Las Vegas. So what happens here is. Oh yeah. Okay, we can always talk about this. You know, at the SolidFire booth. Let me just quickly mention here. I didn't get to go through much of this, but I guess the ultimate goal here was to have this one-to-one mapping between a back-end LUN and a virtual volume. The moral of the story is the 4.2 release enables this through a plugin framework, and then me by implementing the SolidFire plugin, and then making changes in CloudStack's storage architecture, been able to enable this. The hypervisors are moving toward larger support for LUNs, and basically all is good. So I think we're out of time, but totally, if anybody wants to talk to me, I'm going to be over at the SolidFire booth, and we can go through this all day. So all right, well, thanks a lot, guys.